Okay, for all those people who are gone today, we hope that you are well. We are going to talk about ellipses today. Definition of an ellipse is the set of all points whose distances from two foci have a constant sum. Set of all points whose distances from two foci have a constant sum. So what the heck does that mean? I'll share a drawing with you and then you guys can kind of interpret from there. If I have an ellipse, I will draw with my magic smartboard. There we go. Okay. If I have a foci that is here and a foci that is here, if I pick any point, then the two distances, so those distances in the red, should sum the same as the distances in the green. Would you say that those distances, the reds, are the same as the greens if you add them up? No? I think it looks reasonable. Like, you know, obviously this larger green one is longer than that one, right? Well, it's probably made up by that difference there. So that's the technical definition. That's how we can actually come up with these equations. It's a little bit of a proof, but that's the idea. The form of the equation is this. X minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Ellipses may look more challenging than parabolas. They are actually easier. And that's for an ellipse that is stretched horizontally. Okay, an ellipse that is stretched horizontally. If it's stretched vertically, we say this. X minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. Very good. So Easton has pointed out the difference in the two equations. One has a squared under the x term, and one has a squared under the y term. We say that a squared is the larger of the two. So if you see a larger number under y, then that is the a squared term. If you see a larger number under x, then that's the a squared term. So how do we locate these different points? Very simple. First of all, the center is hk, just like our parabolas. hk is the center. Then what we do is we move a units from the center to get to the vertices on the outside. For a vertical parabola, the center is hk, and we move a units up and down. So let's understand these are the vertices, these endpoints right here. And they are a units from the center. So from h, our x value, we move a units to the right or a units to the left. And then the k value stays the same. Notice in this situation, the h value stays the same, but the a value gets added or subtracted from k. I think that the notes are kind of obscure, but it'll make a lot of sense when we do the examples. The major axis is the longer length. What is the length between the vertices here? 2a. And that's the same case for both of them. We haven't talked yet. We talked about how long you stretch the ellipse. We haven't talked about how wide you make it. Maybe you want to guess what that value is? It is b. It's whatever that value is. So the minor axis is 2b. That's how far it's stretched sideways, or widthwise, I should say. Then we have two more pieces. We have foci and we have eccentricity. The foci are the coordinates that sit on the inside that give it its shape. We don't have to find the foci in order to graph it, but they are important points. And the foci sit c units from the center. C units from the center. There's two of them for each ellipse. And now somebody should have a question.
Just because A is involved in sort of the center or the edge of the ellipse.
Yes, C sits between A and the center, and you said how do you find the foci? You need to find C. How do you find C? Thank you. A squared minus B squared is equal to C squared. So it's not exactly the Pythagorean theorem, the subtraction sign instead of a plus sign. That's how you find C. And so the foci sit C units from the center, so H plus or minus C and K. Or H and then K plus or minus C if it's vertical. Eccentricity is a measure of how stretched the ellipse is. And to determine eccentricity, we take the C value divided by the A value. And eccentricity is always a value that sits between 0 and 1. The closer it is to 1, the more stretched it is. The closer it is to 0, the more it just makes a circle. Yeah, B right here you can see is, yep, exactly, thank you. So that would be B, would be how stretched it is that way. All right, you ready to see how easy these are? Yep, same thing. All right, sketch a graph of the following. Find vertices, foci, eccentricity, length of major and minor axes. So I'm going to go center, vertices, length of the major axis, minor axis, foci, and eccentricity. Look at those 6 characteristics. Who can tell me the center? How did you know that, Patty? Good. There's no change in the x or y squared, so it's just centered at 0, 0. So I'm going to sketch this really, really fast. Notice the number under x, it's 4. So how many units is it going to be stretched in each direction? 2 units in each direction for a total of 4. 2 units in each direction, okay? Because the B value here is 2. So I'm going to go 2 to the right, and I'm going to go 2 to the left. There we have it. Now I look at the number under y. It's 25. What's the square root of 25? So that's the number of units I stretch in the y direction. Hello. So that's all we have to do to be able to sketch an ellipse. The graph is completely done. That's all I had to do. I will now identify the characteristics. Yes, Easton.
The x-axis is based on like the square root of the denominator.
The degree to which we stretch it is based off of the square root of the denominator. You said the x-axis is based on, and I can't state x-axis.
Like, for example, I mean, like the x-axis, because you've got 2, square root of 4.
Sure, and then the y-axis 5. Yes. Yep. I think you got it. Vertices are going to be the endpoints of where it's stretched. So vertices here are the top and the bottom, which would be what and what? 0, 5 and 0, negative 5. The major axis is this portion. What is the length of that? 10. The minor axis is this portion, which is 4. In order to find the foci and the eccentricity, what value do I have to find? I must find C. What is my equation for C? A squared minus B squared is C squared. What is A squared? It's always the larger of the two because you want to subtract to get a negative. So 25 minus 4 is 21. So that means C is equal to the root of 21. Somebody approximate the square root of 21 for me. Between 5 and 4, yep, I bet it's about 4.6. So let's go about 4.6 units this way and about 4.6 units this way. And you can see that those are the foci. So I went from 0, I went the square root of 21 up. And from 0, I went square root of 21 down. So those are my two locations for my foci. And my eccentricity is going to be my C value divided by my A value. Or the square root of 21 divided by, what is my A value? Anybody? It is 5. Take out my calculator. I have the square root of 21. I close my parenthesis, divide by 5. I made an error. I pressed go to so I can figure out what I did. Let's try it again. Square root of 21 divided by 5.92. Have a good day, sir. Any questions? So we don't graph eccentricity, but what we do is we determine it, and it can help us identify to what length it's stretched. So the closer it is to 1, the more it's stretched to become like a line. Okay? And then the closer it is to 0, the more it is like a circle. Okay? Yeah. Letter B. I'm not divided by anything. It's not in the right form. Notice that in these two equations up above, that ellipses have to be equal to what? So how will I get this equal to 1? Let's divide through by 36. And you get x squared over 9 plus y squared over 4 is equal to 1. Is it now in a form that I can work with?
Yes.
Yep. Now it should become relatively easy. Just to save myself some space, I'm going to get rid of this previous drawing. What is the center of this ellipse? It is 0, 0. So I'll go ahead and plot that. And now, before I do anything else, I'm going to sketch a graph of the ellipse. How many units am I stretched in the x direction? 3. How about the y direction?
2. No, he's not. You can have a chapter.
Don't jinx it.
Section.
You know what I'm saying. Just give it up.
So there you can see I've already sketched the ellipse by simply just looking at the bottoms. Makes it pretty easy, doesn't it? So we have the center. We're going to list the vertices, the length of the major axis, the minor axis, the eccentricity, and the foci. So I'll go foci and I'll do eccentricity. Very good. All right, vertices sit on the side or the top and bottom? On the sides, because that's where it's stretched more. You go in the direction which it is stretched more. Do you see that? So I've got 3, 0 and negative 3, 0.
You decide if it's horizontal or vertical, if it's based if it's based on when it's more stretched.
Yes. This is the major axis, which has a length of. The minor axis has a length of 4. Can everybody see how these are definite points that we can get on our test? Good. The foci, I need to work through an equation. The equation is a squared minus b squared. So a squared minus b squared. 9 minus 4. So c is equal to the root of 5. Somebody approximate the root of 5 for me. Avery says 2.24. She is 100% correct. So I'm going to do 2.24 units in each direction. And so we're going to go square root of 5, 0, and then negative root of 5, 0. Can't believe nobody's questioned Avery on her calculation of the square root of 5. What if we took the square root of 5? She was right. Good job. Eccentricity, take the C value, which is root of 5 divided by what? A, which is 3. Very good. Square root of 5 divided by 3. Now, is this more stretched or less stretched than the last one? Less stretched. So our number should not be as close to 1. Take the square root of 5 and we divide it by 3. And sure enough, you have an error. I keep doing that. Square root of 5 divided by 3. We have 0.75. Sir. So A is the bigger one. So that's A is the bigger one because we can't come up with a negative. So that's how we actually generate our notes. There's actually probably about 4 different ways to come up with this terminology. After teaching it a number of years, I just believe this is best. Flip it over. What do you notice is different about this one? Yeah, there's a horizontal shift here for the center, isn't there? What is the center? 3, 0. 3, 0 is my center. So I'm going to plot 3, 0. So that's my center. How many units do I go in the x direction? 3. So I go 3 units in each direction. So, and then how many units do I go in the y direction? Yeah, 1, because you see, you know, y squared is divided by 1, and the square root of 1 is 1. I go 1 unit in the y direction. Looks like I get a pretty stretched ellipse. It's kind of fun. Probably not as fun as prom, but probably pretty fun. I heard prom was super fun. Way to go. I heard the change of venue was a nice touch. Good. Should be warm. Should be dancing. All right. What are the other couple things we want to identify? What's the length of the major axis? 6. How about the minor axis? And we have foci and we have eccentricity. I think Gavin watches these videos. So let's put a test in it, okay? If Gavin says the keyword, then he can have a selection of an oatmeal cream pie, or he can have a Star Crunch or a fudge round. What should be the keyword?
Espresso. No, that's just something that would be like strange to say.
What is the key word for Gavin? Whoa, wow. Gavin loves chemistry. He loves chemistry. Okay, if Gavin can say the phrase, and nobody can let him know this, if Gavin says the phrase in class next time he's here, chemistry is overrated, then we'll give him a treat of choice. How's that? Okay, we'll see if he's actually watching the video. We're just wondering, like, we know that when you're gone, you watch video. But what about Gavin? I always wonder about Gavin. He's probably busy doing demadres. What? Of course. All right, here we go. All right, how do I determine the foci? So I have a squared, which is 9, minus b squared, which is 1. So I get 8 is c squared. So what is c? Which is? Good, 2 roots of 2. So 2 roots of 2, everybody knows is approximately 2.8. Very good. We're going to go 2.8 units according to Avery Benda. She's our approximator today. In each direction. And watch how I'm going to write this in my foci. Very good. So we've determined, the foci. So notice what happens for the foci. We have the coordinate 3. That's the x value. And then from 3, we add 2 roots of 2, and we subtract 2 roots of 2, don't we? So I could just write plus or minus 2 roots of 2. And the y value is just 0, right? See how I've taken 2 coordinates and put them into 1? Nice little trick. You can do that when you so choose. And then the eccentricity, I take the c value, which is 2 roots of 2, and I divide that by what? And what is a? A is 3. If I take 2 roots of 2 divided by 3, I should get something pretty close to 1. Wait, 0.94? Avery says 0.94. We'll see how close she is. She's right again. It's like ridiculous.
How do you know these? Are you like working ahead of something? No, Brooke said them and it said. No, it's Avery. Oh, I see.
All right, last one. You're going to do most of this one on your own. It's not in correct form right now, is it? So what do you have to do? Divide by 36 and see what you can come up with. Take the problem for about 3 minutes and we'll finish it the rest of the way. Go. Okay, I'm going to erase that last one. I divide through by 36 and you should get x plus 2 quantity squared over 36 plus y minus 1 quantity squared over 4 is equal to 1. So what is the center? Negative 2, 1. So you're going to go back 2 and you're going to go up 1. And that is your center. That's where you'll base everything from. So I'm going to now sketch the graph. So how many units do I go in the x direction? 6 units. So 6 brings me out here, and 6 brings me all the way out there. So what is this coordinate right there? Not 0, 6, but how about 4, 1? Everybody okay with how I came up with 4, 1? If you go the other direction, I think that would be negative 8, positive 1. How many units do I go in the y direction? 2 units in the y direction, because I'm being divided by 4, the y value. So if I go 2 units up, I'm there, and 2 units down, I'm here. I can now sketch my graph. So it looks like the length of the major axis is 12 units. The length of the minor axis is 4. The foci, how do I determine the foci? A squared minus b squared. So 36 minus 4 is 32. What is the square root of 32? 4 roots of 2 is equal to c. 4 roots of 2, Avery? 5.7. So she's going 5.7 units in each direction. Does that change the x value of the center or the y value of the center? So the x value I will have be negative 2 and then plus or minus 4 roots of 2. And then the y value stays the same. And finally, the eccentricity is going to be 4 roots of 2. And then we divide that by what? 6. And you can see you get 2 roots of 2 over 3, which is exactly what we had in our previous problem, which is 0.94. Good work. Parabolas, or ellipses. Tomorrow we do hyperbolas, and then Wednesday you have a day to work on all 3 of them. Okay? Good job, everybody.